Hello geometry students, welcome to the continuing series of videos here on properties of chords, and we're moving on to another theorem, but this one is very similar to the other one, to the theorem 10.4. So this is really the converse of theorem 10.4 that we just did up here, and I am not going to prove this one. I'm only going to demonstrate what it says. So it says here, if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. Okay, so I'm going to draw the same picture, except this time the conditions are a little bit different. The statement of the proof is different. So if CD is the diameter, okay, so in the last proof, we had to show that CD is the diameter. This time, we can assume that CD is the diameter, and CD is perpendicular to AB. Then, CD bisects AB. Okay. So, if this is the diameter, and this angle is 90 degrees, then we know that the diameter cuts the chord exactly in half. Okay, and I'm not going to prove this here in these notes because I want you to practice doing this, and this is going to be part of your homework assignment. So I'm going to move on now and just explain one more problem, or one more theorem rather. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. Okay, so let's say you have a chord. Let's say this is AB, and this one over here is CD. Okay, and the center is Q. Okay. So there's two parts of this as well, and part one says if AB is congruent to CD, so if they are the same length, then AB and CD are equidistant from the center, equidistant from Q, which in this case is the center. And the second part is the converse of that. If AB and CD are equidistant from Q, then they're congruent to each other. Okay. If AD and CD are equidistant from Q, then AB is, this should be AB, okay, is congruent to CD. Okay. So I'm going to prove one of these parts in this video so that you get the hang of what this statement is saying. Okay, so I'm going to prove part 2 here. So if AB and CD are equidistant from Q, in other words, or given, okay, what's given here is that from Q to AB, and remember the distance from a point to a segment is the segment that's perpendicular to it, and this other part here, okay, given that you have these segments and they happen to be congruent to each other, then we have to show that somehow AB is congruent to CD. Okay. So to complete this proof, it's a very similar concept to what we've been doing, which is we're going to start out by making these constructions, just drawing in these radii. And then I think I'm going to call this point here F, and this point here G, just so that we can reference them. And I'm going to do a flow proof just to mix it up a little bit and make sure you get the same ideas here. So I'm going to start out by saying I'm going to build it up from the bottom up. I'm going to say that these segments here are all the same, So those 4 segments, because they're radii. And at the same time, GQ and FQ are also the same. The blue segments are also the same. And that was just given in the problem. And that was just given that AB and CD are equidistant from the center. Okay? So now these 2 items together help me to show 2 important things. It helps me to show first that these 2 triangles here are congruent by hypotenuse leg. Okay? So I get one set of triangles here that are congruent by hypotenuse leg. But if you notice, I also get these 2 here, these blue ones, that are also congruent by hypotenuse leg. And they come from the same reason, because this is the hypotenuse here, and this is a leg. So that's triangle DQG and triangle BQF. Triangle DQG and triangle BQF are also congruent by hypotenuse leg, which means that, and let me get to another color here so this will be a little bit easier to see. So what it means is that this length here and this length here are equal. The 2 yellow lengths are equal. And not only that, but of course these lengths here must also be equal. So this length and this length here are also equal. Okay? Both by CPCT. So then we can complete the proof and say that CD is equal to AB. Okay? So I get this result. This is the BF and DG result, that's those segments. And then I get this result right here, both by CPCT. And if you notice, again, if I add them together, the pink and the yellow is equal to the pink and the yellow, and that's AB and CD, which is what we've been trying to prove. Okay, so here's a flow proof. Looks a little bit more complicated, but it's another way of just doing a proof. You can certainly use the flow proof or some other proof if you'd like. That's where we're going to stop here. If you are in Mr. Wen's class, this is the end of your notes, and the practice problems, you can start working on them, but we will also work on them during class. Thank you for watching. Have a wonderful day.